Hello and welcome to bitstream24. My name is Wilfried Voss and bitstream24 is my personal technology blog. Today I would like to talk about a comparison between controller area network and industrial Ethernet. But before I continue, for those who would like to download this presentation is already stored on our website at bitstream24 YouTube-channel, and if you didn't get the hyperlink right now, then I will show the slide at the end of the presentation for further reference. At first glance, a comparison between the two networking technologies, controller area network or CAN, and industrial Ethernet may appear as a battle between David and Goliath. On one side you have the clear underdog, which is CAN with its 1 megabit per second baud rate, its limited network length and a maximum data length of 8 bytes per message. Compare that to the various industrial Ethernet solutions such as Ethernet IP, EtherCAT, Profinet, Ethernet PowerLink, Modbus TCP and Circus 3. They provide a standard 100 megabit per second transmission rate, and it even goes up to 1000 megabit per second. They have unlimited data package sizes and a virtually unlimited physical network length. In view of these raw performance data, there appears to be no contest at all. It appears there is nothing better than industrial Ethernet. However, that assessment will change in view of two parameters that may be easily neglected. First, there is the type of application, and secondly, the budget. And for the record, this is not an attempt of boosting the image of an older but inferior technology like CAN or denying the strength of industrial Ethernet. The point is that both have their strengths and weaknesses depending on the type of application. CAN is definitely a suitable choice for small size controls. That is, embedded solutions that require multiprocessor communication. Industrial Ethernet unfolds its vast performance specifically in the larger networks for automation and control of production machinery, including production monitoring. And production monitoring is a very important aspect. But some of you may say, hey, wait, are we missing something here? What happened to higher layer protocols such as CAN Open and DeviceNet? Aren't they supposed to close the gap between mere embedded solutions and factory automation? However, it is fair to say that CAN higher layer protocols such as CAN Open and DeviceNet have been overpowered by industrial Ethernet. And quite frankly, in my very personal opinion, CAN Open and DeviceNet are dead in the water technologies when it comes to new developments. And yes, there are a great number of legacy applications that provide some life support, but the days for CAN Open and DeviceNet are clearly numbered. These two protocols are, in terms of performance for distributed control, devoured by industrial Ethernet. CAN Open and DeviceNet were designed to overcome the disadvantages of CAN, specifically the implementation of network management. For instance, mere CAN does not support node IDs. They were also designed to extend the available data size. And still, they cannot overcome the limited physical network length, and they have a tremendous impact on the bandwidth. In fact, in the worst case scenario, the effective bandwidth can be as low as 25%, meaning that only 25% of the information transmitted is actual data. If you combine that with a maximum baud rate of 1 megabit per second, then you see the vast disadvantage compared to industrial Ethernet. And as a consequence, it takes great efforts for software development and design to squeeze a suitable performance out of CAN Open and DeviceNet. And of course, industrial Ethernet does come with its own challenges in regards to careful network design, specifically the prudent implementation of routers and hubs. But it does not come with the headache of network length and bandwidth consideration, and per default, it saves a great deal of investment during the design and implementation phase. Industrial Ethernet also offers new perspectives for the manufacturing process that were not possible with CAN Open and DeviceNet, specifically the access and transmission of production information. Now, just as a reference for the beginner and for those who are more interested in the technology, a brief explanation of CAN. CAN is a two-wire half-duplex high-speed network system that is superior to conventional serial technologies such as RS-232 in regards to functionality and reliability. It prevents message collisions and provides excellent error detection and recovery. For the longest time, the major misconception about CAN was that it is merely used in automobiles. The truth is CAN proved to be a robust, simple, and versatile technology, and consequently it found its way into all areas of applications where microprocessors need to communicate with each other. CAN was designed with real-time requirements in mind, and even with its low 1 megabit per second baud rate and a maximum data length of 8 bytes, it can easily beat a standard 100 megabit per second TCP/IP connection when it comes to reaction times, error detection, error recovery, and error repair. And again, I'm referring here to standard TCP/IP, which is not necessarily identical to industrial Ethernet. However, CAN is limited to a physical network length of roughly 40 meters or roughly 120 feet at 1 megabit per second. Now let's have a brief look at industrial Ethernet. The term industrial Ethernet needs further clarification as it may be interpreted as mere industrial strength Ethernet. I use the term in reference to real-time industrial Ethernet because for many engineers in the automation industry, industrial strength is not possible without real-time. In order to explain industrial Ethernet, we need to compare it to standard Ethernet, also known as Ethernet TCP/IP. The simple and effective design of the standard Ethernet TCP/IP protocol has made it the most popular networking solution at the physical and data link level, especially for general-purpose office networks. With high-speed options in a variety of available media types, Ethernet TCP/IP is efficient and flexible. However, the unpredictable nature of TCP/IP in terms of timing has been a drawback for many industrial network applications, specifically those with real-time requirements. Yet, as the overall cost versus performance has improved over time, industrial users have developed methods to overcome these apparent shortcomings. The implementation of additional real-time data exchange protocol layers or add-on software incorporated prioritization, synchronization, and other techniques to ensure the timely delivery of messages. In addition, the segmentation of networks through intelligent Ethernet switches resolved the problem of bus congestion and message collisions. Some protocols such as EtherCAT, Profinet version 3 and Circus 3 go even further by modifying the physical layer. Like Ethernet TCP/IP, industrial Ethernet supports a 100 megabit per second transmission rate, and it goes even up to 1000 megabit per second. It has unlimited data package sizes and a virtually unlimited physical network length. However, unlike CAN, industrial Ethernet requires great hardware and software resources. In order to compare the technologies here, we have to look at the OSI reference model. The OSI reference model is at the heart of all serial networking technologies, including controller area network and industrial Ethernet. The reference to the model is helpful when it comes to a comparison of networking technologies, especially the degree of OSI model implementation. The Open Systems Interconnection Reference Model, or OSI model for short, is a layered, abstract description for communications and computer network protocol design. The model describes and standardizes the data transfer between networked devices in an open architecture. Now let's have a look at how standard Ethernet TCP/IP refers to the OSI model. Without going into all details of TCP/IP, the picture as shown here effectively demonstrates the implementation of the OSI model into TCP/IP. The downside to standard TCP/IP is that it does not support real-time requirements as demanded by most industrial applications. Especially the CSMA/CD and UDP components are a drag in terms of real-time performance, meaning there is a lack of determinacy. In simple terms, industrial Ethernet is Ethernet TCP/IP enhanced by add-on software, so-called real-time data exchange modules. They address the non-deterministic features of Ethernet TCP/IP and therefore accomplish real-time control. But there are two different approaches to accomplish real-time control, and one is with a mere addition of real-time data exchange software modules, and others even go so far as to modify the physical layer. In stark contrast, a CAN implementation is far simpler than industrial Ethernet, meaning that despite its technological shortcomings, it is very easy and inexpensively to implement. The standard CAN implementation bypasses the connection between the data link layer and the application layer in order to save on valuable memory resources by minimizing the overhead and as a result gaining performance as needed for embedded solutions with limited resources. While this concept may appear inferior to other protocols, including industrial Ethernet, controller area network is an ingenious solution for implementing real-time capabilities on a serial bus designed for embedded solutions. Coming to the conclusion, controller area network or CAN and industrial Ethernet are two very different networking technologies, and each one is very suitable for their respective niche in the automation market. CAN is definitely a suitable choice for small size controls, that is, embedded solutions requiring multiprocessor communication. CAN requires only small resources in terms of CPU power. In fact, even a simple 8-bit microprocessor can handle the CAN communication without problems. If your application is budget sensitive, there is no better choice than CAN. Even a low-cost RS-232 solution will not be as cost-effective as CAN, and on top of that, CAN provides great features such as error detection, error recovery, and the prevention of message collision. In compact multiprocessor systems, CAN will reduce the amount of wiring significantly, and thus increases the reliability and reduces maintenance and troubleshooting efforts. Industrial Ethernet's vast performance unfolds specifically in the larger networks for automation and control of production machinery, including production monitoring. The performance and decreasing hardware costs make it a fierce competitor, if not a killer, of other established networking protocols, including, but not limited to, CAN, Open, and DeviceNet. And of course, it requires significantly larger hardware resources than CAN, but the result is well worth the expense. Industrial Ethernet will reduce development and design costs compared to CAN, Open, and DeviceNet because it does not require any time-consuming performance tweaks. And a reference for those who are interested to read more about the details of CAN and Industrial Ethernet. First, there is my book, A Comprehensible Guide to Controller Area Network, and it is available at Amazon, Barnes & Nobles, and 8books.com, That means it is available all over the world. And again, it gives you a detailed documentation of the CAN protocol. And secondly, I am in the process of preparing another book, a comprehensible guide to industrial Ethernet, which I'm planning to release in the spring of 2014, and it will be available at Amazon, Barnes & Noble, apebooks.com, and that means it will be available all over the world. If you are interested in receiving updated information about the release of that book or any other information, I would like to encourage you to sign up for our newsletter at bitstream24.com, and as it shows here on the screen, there will be no spamming, and this will be just an occasional note, and you can unsubscribe at any time. And yet again, you can download this presentation in form of a PDF file at the hyperlink as shown here on the bottom of the screen, and that is bitstream24.com/YouTube-channel. Thank you very much for listening to my presentation, and hope to see you soon. Thank you.